Hello friends, welcome to next part in blog series on developing an OCR Vision AI. As we saw in previous blogs, this is the chatbot Vision AI application we are going to build. Our end product is going to look exactly like this application. In our previous post, we discussed a high-level solution architecture diagram. We covered a lot of theory how our system application is going to look like from architecture perspective. As we discussed that we are going to build this entire application one step at a time. So in this blog today, we are going to focus on one such component, that is create a FAISS Vector database for creating data index store. Just to let you know that I've already covered this topic in extensive detail in past. Check out this face recognition AI application. This app is capable of indexing 10,000 images on a CPU using 5x indexes, and the response time is within 7 to 10 seconds. So if you're finding this Vision AI blog for the first time, please take some time to review my earlier post to get some background. Here is the X link where you can find this blog, and if you go to my profile and browse to X highlights, you'll find this video blog there. Similarly, if you browse to my YouTube channel, and you will see the same video there. And if you are a pro developer and just want to see code, you can go to my GitHub repository directly, and while you are there, I request you to please follow up my X account, which goes by handle ashuklax, my GitHub handle amitx.shukla, and subscribe to my YouTube channel at amit.shukla. So in today's section, we are going to focus only on one building's functionality. That is address how to build a FAISS functionality. Let's get started. Initializing a FAISS index store. So as I stated earlier, we are not going to worry about other parts of application for now. In this section, we are going to write code to address one specific problem. Once a file is dropped, it's going to trigger some local AI logic or built-in process. Now this process reads the data and then write the data to SQL and a vector database. In past videos, we worked on a file drop component, and we also set up a SQLite database. Similarly, in today's blog, we are going to set up and build a FAISS Vector store. So if you want to know more about FAISS Vector Index Store, please refer to the previous videos links I have shared. Setting up a FAISS Vector Index. So in case if you don't know, Facebook AI Similarity Search is known as FAISS. It's an open source library developed by Facebook. It is designed for efficient similarity search and clustering of dense vectors. It is widely used for tasks involving nearest neighbor search in high dimensional vector spaces. So it's very useful in case if you are working with image processing tasks. First, make sure that you have FAISS installed on your machine. You can install it using simple pip command. So just open a terminal window and issue a command saying pip install FAISS-CPU. And if you have a GPU machine, and if you want to install the GPU version, just change your command to pip install FAISS-GPU. Now that you have FAISS installed, let's import two Python packages, import FAISS and import numpy as np. Now let's create a function which create the FAISS index, and we are going to break this code step by step. First line is def create FAISS index, and you pass the data as a parameter. So this line defines a function named create FAISS index that takes one parameter, which is data. Now we convert data to a numpy array of type float32. So data equals to np.array, you pass the data, and you say as type, you cast it to as type float32. This line converts the data to a numpy array with a data type of float32. Now this ensures that data is in the correct format for further processing. Now we need to get the dimension of the vector dimension. So you write dimension equals to data.shape 1. So data.shape, it retrieves the dimension of the vectors in the data, which we store in a variable called dimension. And data.shape1, it gives the number of the column in that array, so which corresponds to the dimension of each vector. Now finally, in next step, we create a FAISS index. So write index equals to FAISS.index flat L2, and you pass the dimension. Now FAISS.index flat L2 dimension, what it means, it is initializing an index that uses the L2, which stands for Euclidean. So L2 distance, which is a metric for the given dimension. Now you are adding data to that index. So simply write index.add and you pass the data into that. So this add method on the index is going to insert the vectors into the index. And finally, you just simply write return index. So this line returns the created FAISS index. So in summary, in short, what we did, we created a function which converts the input the data to a numpy array of type float32. It determines the dimension of the vectors and then create a FAISS index using the L2 distance metric, and then finally it adds the data to the index and return that index what you just created. Now we are ready to pass the data. So let's create a simple data array which has 5 vectors or dimensions 3. So which means it's 5 rows and 3 columns. So data equals to and create that array. So at this point, this data is made up of floating point numbers. And later when we use Gen AI, we are going to take our OCR text, convert those into manageable tokens and convert those to floating point numbers. So that's going to look exactly like this, what we are passing right now in the data variable. And we are going to use embedding tokens to do that. This may be a little hard to digest right now, but we'll cover this in extensive detail later on. For now, just for the clarity, think about this data variable containing your OCR text in format of floating numbers. Now let's create and populate the FAISS index. So write index equals to create FAISS index and pass the data to this function. This line calls the create FAISS index function what we discussed earlier. And we are just passing that data as an argument. Finally, this function returns a FAISS index populated with the vectors from the data. So in next line, print the number of vectors in the FAISS index. Index.endTotal, that's what it gives, the total number of vectors stored in that index. Now at the end, we write the line name equals to main, if name equals to main. So what this line, it checks if the script is being run directly as opposed to being imported as a module in another script. So in Python, this is a special variable called double underscore name followed by underscore is set to main. So when this script is executed directly, that means if the script is imported, double under name is set to the script's name. So what it means, if the condition name equals to main is true, this line calls the main function defined earlier in the script. So in summary, this code ensures that main function is executed only when the script is run directly, not when it is imported as a module. That's the only difference. Now, this is very common practice in Python to allow code to be reused as a module while also we're providing a way to execute some code when the script is run directly. All right. That's all I wanted to cover in this video today. So in this video today, just to recap, we have set up a FAISS vector index store, which we are going to use it for image processing later. In next videos, we are going to dive into more and more deeper, and we'll create more next components to support our Vision OCR AI application. So in case if you have any issues, please feel free to open an issue log at my GitHub repository, and I'll be happy to help you out. Stay tuned. Thank you for watching.